Today's lesson is on various things in trig. Most of this will be a review. A lot of it is terminology that you need to know. First term, angles that are in standard position. If they are in standard position, the vertex is at the origin. And the initial side is the positive x-axis. So if we were to draw an angle in standard position, there is an angle in standard position. We measure going this direction here. A commonly used variable is to call this angle theta. The positive x-axis is the initial side. And where this angle ends up, we call the terminal side. Okay, next, converting between radians and degrees. So we talked about radians and degrees on the unit circle. If you remember, 180 degrees was equal to pi radians. So if I want to solve each side of this equation, if I divide by 180, 1 degree is going to equal pi over 180 radians. If I divide both sides by pi, 1 radian is going to equal 180 over pi. So let's do an example. We're going to convert to radians. So 135 degrees, if 1 radian equals pi over 180, then 135, we will multiply that by pi over 180 and then reduce the fraction. This is going to end up being 3 pi over 4. And it is one of our unit circle values, so that should make sense. Our next example, we're going to convert to degrees. So the given angle is 2 pi over 3. So we're going to take 2 pi over 3 and then multiply that by 180 over pi. And if you ever forget which direction, you can always just set up a proportion. Or just looking at it, I need the pi's to go away, so the pi's got to go in the bottom. So this is going to simplify. The pi's will cancel. We're going to have 2 times 180 divided by 3, which ends up being 120 degrees. Next vocabulary term is coterminal angles. Coterminal angles are angles with the same terminal side. So what we're going to do is add just a full rotation, which is going to be 360. So it's going to be theta plus 360 as many times as we want, or adding 2 pi as many times as we want, where k is an integer. So that includes adding and subtracting. So you might want to pause and write this down. Our example is going to be identify all angles coterminal with the given angle, then find and draw one positive and one negative coterminal angle. So all angles that are coterminal is going to be 80 plus 360k, where k is an integer. I can find one positive and one negative by adding 360, which gives me 440, or subtracting 360, which gives me negative 280. To draw that, okay, 80 degrees would be about here-ish. So that's 80. We're not going to draw another angle because if they're coterminal, it's the same thing. It's just how we get there. So the 440, we're going to start here and go all the way around this direction. For the negative 280, we're going from this side. Negative angles are measured going counterclockwise. So this would be negative 280. Okay, now we're going to be talking about trig functions on the unit circle. Before we talk about this unit circle, we're going to talk about trig functions of any angle. So we're going to draw an angle in standard position. Okay, there's going to be my theta. This is x. This is y. We call this distance r. R can be found using the Pythagorean theorem, so x squared plus y squared. So we have 6 different trig functions, and we can use right triangle trig and this picture here to make these relationships. So sine of theta is equal to opposite over hypotenuse, which on this triangle is going to be y over r. Cosine is adjacent over hypotenuse, so that's going to be x over r. And then tangent is going to be opposite over adjacent, so that's going to be y over x. There are 3 related trig functions called the reciprocal trig functions. Cosecant is the reciprocal of sine, so that's going to be r over y. Secant is the reciprocal of cosine, so that's going to be r over x. Cotangent is going to be x over y. Okay, now we're going to look at the trig functions by quadrant. So I'm going to put sine, cosine, and tangent in each of these 4 quadrants. So in the first quadrant, sine is, and we're just looking at the x's and the y's. So since x and y are both positive, all of these are going to be positive. The x is positive, so cosine is positive. Y is positive, so sine is positive. Tangent is positive because y over x is positive. In the second quadrant, the x value is negative. So cosine is going to be negative. Sine is going to remain positive. But tangent, since it's going to be the y over the x, is going to be negative. In the third quadrant, both x and y are negative, so sine and cosine are negative, but that makes tangent positive. And then in the fourth quadrant, sine is going to be negative, cosine will be positive, tangent will be negative. So there's a mnemonic here that you may remember. All of the trig functions are positive here. Sine is positive here. Tangent is positive here. And cosine is positive here. So if you remember all students take calculus, then you can remember the signs in the different quadrants. Okay, next term we're going to talk about is a reference angle. The reference angle is the acute angle formed between the terminal side and the x-axis. So we're going to look at what this looks like in each quadrant. All right. My first angle I'm going to draw here is 30 degrees. Okay, if that angle is 30 degrees, the angle formed between the x-axis and the terminal side is also going to be 30. Now in Trig, your Trig book had a little special character it used. There's not really a general thing for that, so I'm just going to say reference angle is 30. Next angle I'm going to draw in the second quadrant is going to be 150 degrees. The reference angle is the angle formed between the x-axis and the angle. So this angle here. Well, if this is 150, that angle is going to be 30. So this one's reference angle is also 30. This angle is going to be 210. The reference angle, if this is 210, that angle is going to be 30. It's at 30 degrees more than 180. So my reference angle is again 30. Okay, thinking about my pattern here, my last one, this angle right here is going to be 330 degrees. So this angle is also going to be 30, which means that our last reference angle is 30 degrees. So our next example, we're going to sketch each angle and find its reference angle. So the first one's going to be negative 120 degrees. So negative 120. Positive angles are always measured going counterclockwise. Negative angles are measured going clockwise. So 120, negative 120, is going to be about here. So that's negative 120. The reference angle is going to be the angle formed here. It's always going to be a positive value, so even though this is negative, I want to know physically what is this angle here going to be. Well, if this is 120, that means this angle is 60, and that's going to be my reference angle. Next one I'm going to do is 3 pi over 4. Okay, 3 pi over 4 is halfway in this quadrant. So this is 3 pi over 4. The reference angle is going to be the angle here. So how much more would I need to get to pi in this case since we're in radians? So this answer is going to be pi over 4. Next example, let secant theta equal root 29 over 5, where sine of theta is less than 0, meaning sine's going to be negative. We're going to find the exact values of the other trig functions. I'm just going to draw myself a triangle. There's theta. If secant is root 29 over 5, that's the reciprocal of cosine. So cosine is adjacent over hypotenuse, which means this is hypotenuse over adjacent. Or we can think about it with secant from our, so this is x, this is y, this is r. secant of theta is r over x, so that means my r is root 29 and my x would be 5. So this is 5, this is root 29. So then we need to solve for y. So 5 squared plus y squared equals root 29 squared. So y squared equals 4, so y is 2. So it could be positive or negative, but here's what we're going to do. I'm going to write down all the trig functions that I'm trying to find. And I'm going to include secant even though I already know what it is. Okay, I'm not going to worry about positive and negative except for this one time. Okay, if secant is positive, that means cosine is positive. We're told sine is negative. So what quadrant is cosine positive and sine negative? That's going to be in the fourth quadrant. Tangent will also be negative. So here I'm going to go ahead and assign. Sine is negative, which means cosecant is negative. Tangent is negative, so cotangent is negative. Cosine and secant are going to be positive. Okay, so sine is going to be the opposite over hypotenuse, so a negative set 2 over root 29, which you can rationalize if you want to, which means cosecant is root 29 over 2. Cosine is going to be 5 over root 29. Secant we already know. And then tangent's going to be the y over the x, so a negative 2 over 5. Cotangent is going to be the reciprocal. Next, we're going to talk about trig functions on the unit circle. So if you haven't watched the unit circle video, please do that. And you may want your unit circle handy for this. So on the unit circle, we labeled a whole bunch of angles and a whole bunch of coordinates. Okay, so we gave each coordinate for various angles. So this is x, this is y. On the unit circle, the radius is going to be 1. So you can think about this is theta. With right triangle trig, you can think about it using our previous definitions. I always go back to right triangle trig. So sine is going to be opposite over hypotenuse, which is going to be y over 1, which is y. Cosine is going to be x over 1. Tangent is going to be the y value over the x value. And then our reciprocals. Cosecant is 1 over y. Secant is 1 over x. Cotangent is x over y. So on the unit circle, each of the coordinates gives us the cosine value of the angle and the sine value of the angle. And then the rest of them we can do some simple calculations to get. So we're going to find the 6 trig functions for some different angles. So let's just try 30 degrees. So we go to the unit circle and you find 30 degrees. And the coordinates that we're interested in are root 3 over 2 and 1/2. So from that, I'm going to be able to find all 6 trig functions. Sine is the y value. Cosine is the x value. Tangent is the y value over the x value, which is going to be, I'm going to do some calculations down here. That's going to be 1/2 divided by root 3 over 2, which is 1 over root 3, which is going to be root 3 over 3. We traditionally write that rationalized. So tangent is root 3 over 3, and then these will be the reciprocals. So cosecant, and I shouldn't write theta here, that's 30. Cosecant 30 is going to be 2. Secant of 30 is going to be the reciprocal of this rationalized, will be 2 root 3 over 3. And then cotangent 30 would be this flipped over, which is just going to be root 3. Next, I'm going to do 7 pi over 4. So we look at the unit circle, find 7 pi over 4, and look at its coordinates. So it's root 2 over 2, negative root 2 over 2. So sine 7 pi over 4 is equal to negative root 2 over 2. Cosine is positive root 2 over 2. Tangent is going to be the y over the x. Well, these are the same thing, just one is negative, so this is going to be negative 1. The reciprocal of this would be negative root 2. Secant is positive root 2, and cotangent is a negative 1 again. Last one of these we're going to do 180. So the coordinates at 180 are negative 1, 0. That means sine of 180 equals 0. Cosine 180 equals negative 1. Tangent 180 is going to be the y value over the x value, which is going to be 0. Cosecant 180 would be 1 over 0. So this is undefined. Secant is going to be 1 over negative 1, which is still negative 1. Cotangent is going to be the x over the y, which is going to be negative 1 over 0. So this is undefined. Okay, we're going to use the unit circle to find the exact values of some angles that are not on the unit circle. Okay, so cosine of 9 pi over 4. 9 pi over 4 is not on our unit circle. It's bigger than 2 pi, because 2 pi would be 8 pi over 4. So what I'm going to do is take 9 pi over 4 and subtract 2 pi, because that would be a full rotation around the unit circle. So it's going to be minus 8 pi over 4, which is pi over 4. So cosine of 9 pi over 4 is going to have the same cosine value as pi over 4. Using our unit circle, that's going to be root 2 over 2. Sine of negative 300. You could just find it on the unit circle by going clockwise to 300, Or we're going to just add 360, which makes this the same as sine of 60, and the y value at 60 is root 3 over 2. We'll find the tangent of 29 pi over 6. So again, I'm going to subtract 2 pi. So 29 pi over 6 minus 2 pi, which is the same as 12 pi over 6. That gives me 17 pi over 6, which isn't all that helpful. So let's subtract another 2 pi, which is 5 pi over 6. That is on our unit circle. So this is going to equal the tangent of 5 pi over 6. So I go to the unit circle, and the y value over the x value there is going to give me negative root 3 over 3. So complete each trig expression. Sine 30 equals cosine blank. Okay, so what we're going to do is go to the unit circle and find the cosine of 30. The y value at 30 is 1/2. So now what I want to do is figure out cosine of what angles would also give me 1/2. So I'm looking for where the x coordinate is 1/2, which is going to occur here and down here. So at 60 and 300. I'm just going to do a comma there. 60 and 300 give me this cosine of 60 is equal to sine of 30, and cosine of 300 is equal to sine of 30. Cosine of pi is equal to tangent of what angle? Well, cosine of pi is equal to -1. So we want to find the locations where tangent is also -1. That's going to occur at the 45s where the coordinates are the same, but opposite signs. So that's going to be at 3 pi over 4 and at 7 pi over 4. So that is trig functions on the unit circle.